So today we're going to be talking about polygons. A polygon is a simple closed figure formed by 3 or more line segments called sides. The key to this definition and to identifying a polygon is that the polygon must be closed. Okay, if you notice here, each of these is a closed figure. None of them are diagonal or three-dimensional does not count. The lines do not cross over. There are no curves. Okay, if you notice, every single one is a straight line. So we're going to talk about identifying them. So you basically want to say, well, none of these lines cross over each other. And then you just have to count how many sides. 1, 2, 3, 4, 5, 6, 7. So then I look up here and I say, well, there are 7 sides, which means this must be a heptagon. Oops. Heptagon. These you will want to remember. It will help you throughout the rest of the geometry unit. I'm going to go ahead and let you identify all of these. This is the main part we want to focus on. We're talking about diagonals. Diagonals are line segments that join 2 non-consecutive vertices on the polygon. So non-consecutive means not next to each other. Or they're not touching. Okay? So if we look below, okay, we're talking about how this vertice is touching this vertice. Notice the sides that connect are not actually touching each vertice. So a quadrilateral can be broken down into 2 triangles. This is how you can break down quadrilateral, a pentagon, hexagon, and octagon. This equation right here is what you are going to want to do or use in order to find this sum, the sum of the degree of measures of the interior angles. So the total degree inside a polygon, if this definition does not make sense to you. So the first thing we want to do, I've given you an example step by step. Notice that the number of triangles is 2 less than the number of sides. This is just patterns that you can find. So you know that it is always going to be 2 less. So notice back here we had 4 sides minus 2 is 2 triangles. 5 sides, 2 less, so 5 minus 2 is 3. 6 sides minus 2 is 4, and 8 minus 6. So this is just a little pattern to help you remember the formula. We have find the sum of the measures of the interior angles. So they want you to use this formula. And n, so n equals the number of sides on the polygon. So you notice that instead of n, we had replaced it with 9, the number of sides on the polygon, which then got us 7. And then we used our distributive property or multiplication, since we know parentheses means multiplication, and we got 1,260. Notice that you have it written with a degrees. That is the sum of all the inside angles. Okay, so I'm going to go ahead and do one more. We know that our equation is n minus 2 times 180. So we have a 13 gone. So I'm going to replace my 13 with n. So we've got 13 minus 2 times 180. Okay. And
Isaiah Griffin to the office. Isaiah Griffin, please report to the office.
Then we have 13 minus 2 is going to be 11 times 180, which will get us 1,980 degrees. Go ahead and try these on your own and come show them to your teacher. We will talk about regular polygons in the next video.